Hi guys, hallo julle. This is the third video in the series on solid geometry. Dis die derde video in die reeks oor vaste liggame en snitte vir graad 12. Ons werk op die oomblik op bladsy 65. As jy nog nie die vorige twee video's gekyk het nie, gaan kyk hulle asseblief. Okay guys, so in this video I'm going to focus basically on this area over here, which is my left view. Now guys, there's always this one thing that I think that makes it difficult for the students to understand how to get this view over here. Now if you understand what's in front of you, I think it should be easy enough for you to basically get this view. It's not too difficult. But for those of you guys who are unsure, I'm just going to give you guys a little bit of background. I think this should assist you in a big way. So remember, when we draw this, this is actually a box, the first angle. And this box can fold open, and it can fold open like this. And I can fold the whole box. I'm not going to do that now. But I'm just quickly want to show you guys a specific thing. Now, there's this method that we teach the kids in school. And I always like to explain to the students why we do this. Now, it's not everybody that really needs to know this, because you need to be able to apply this method. Now, when I was in high school, they taught us this punt, grondlyn, punt, grondlyn, punt. But they never taught us why. Now, I love it to understand and to be able to tell people why we are following this method. And it's actually very simple. What this comes down to is the following. If I've got any 2 points of the same number. Okay, so if I've got a point 1 over here, and I've got a point 1 in another view, and those two views are next to one another, I can basically use those numbers to get the same number in a different view. In other words, in the left view, in an auxiliary view, in the right view, doesn't matter. It can be any two views as long as they are directly next to one another. In other words, like these two or these two or those two. So it doesn't matter. Okay, but they must be next to one another. So let's quickly work with point 1. Guys, so 1 is basically these 2 points like I mentioned earlier. And if I turn it like this, you'll see it's 2 points. So if I want to get point 1 into that view, why then do I use this method? So how it works is I can say to myself, if I've already drawn these two views and I've got nothing here, and I want to start drawing this now, I'll first draw a line across, and then I'll say, okay, what is in line with basically with the point I want to draw? I first of all decide which point I want to draw. In this case, it's point 1. So I check point 1 is on 2 heights. So I draw a line from there, and I draw a line from there. Then I say to myself, somewhere there's going to be a point 1 here. So I say punt, grondlyn, punt, grondlyn, punt. So the grondlyn is basically the XY lines. Okay, the XY lines are the division between the surfaces, like I mentioned earlier, the surfaces that actually, distinguish my views from one another. But remember, these are projected views. So what basically happens is you're going to say the distance from the XY line up to point 1 should be exactly the same distance as from the XY line to point 1 over here. Now guys, basically how does this work? Let me quickly and very simply explain to you guys where does this come from. Okay, so if you guys see the distance over there, the same distance can be measured in this view. Now this applies to all my points, but I measure from the XY line. It doesn't matter what drawing you get, this will be exactly the same. Where does this come from? Let me explain to you guys. If I'm looking from the left hand side of this view, and let's say for instance I still had a surface here where my hand is, the same space that you guys see over here, which is now at the back of the drawing. Now what I'm going to do is I'm going to put this red pencil here at the back. So please remember that red pencil. That red pencil indicates the distance from this object to this vertical plane, this surface here at the back. So if I'm going to take that pencil together with my view and I draw my front view, now this red pencil is here at the back, but it's still there. And that is the same space that you guys see here. So that is the 10 millimeters that are visible here. If I now take this same object and I swivel it to get my left view, now just see where this is. It's exactly at the same side. So if I say, for instance, this space that you see here from the XY line to 2 is exactly the same distance that you see from the XY line to 2 over there. That means that this distance here and that distance there is exactly the same. And that is the reason why we can apply a method that we say punt, grondlyn, punt, grondlyn, punt. So in other words, punt, grondlyn, punt, grondlyn, punt. If I'm working with point 2, for instance, in this case, there's 2, there's 2, and there's 2. I can do the same thing at the top. So there will also be a point 2 there. There's also a point 2 there. And there's also a point 2 there. So same thing. Punt, grondlyn, punt, grondlyn, punt. Grondlyn is the XY line. Guys, if you don't understand this whole explanation, that is okay. Just remember you need to be able to apply that method. Okay? So guys, that is the first thing I want to mention. So once again, before you do anything else, you are going to draw this left view. So you're going to draw the outline, you're going to draw the hidden lines on the inside. Once again, you are going to start with your prism. You're going to say to yourself, it's a sectional left view. So I'm cutting away this part over here. So there's my object, there's the cutting line. This area will be taken away and I'm going to swivel it towards myself that I can see it. So simply put, you're going to take these same points in this case, you're going to project it over. And you can see there that point 1 will be on 1. You can see that 6 and 2 will basically be over there and over there. And that is why it's important to also number as you are taking, if you are measuring and you're taking points over, to actually mark them. Another thing that I forgot to mention is that if you don't want to use this punt, grondlyn method in this case, because the object is in a normal position, in other words, the axis of the object is 90 degrees on the surface, which simply means that it's standing flat on the horizontal plane here at the bottom. Then it's not necessary for auxiliary view. You guys will see in the other exercise later on, if something is angled, you're going to have to draw an auxiliary view. That's the same thing as what we've got here. It's basically this view then just swivels with that view. Okay, but we can look at that in another video. So guys, very important now, you can also get this view by just simply projecting over and up. So if I'm taking 2 over and up, I can also get 2 there, and I can bring 2 over from there, and in that way I can easily get my points as well. So that's just something I want to add in there that you can also use to complete this drawing. Okay, so guys, then like I mentioned, you're going to plot all your cutting points of your prism. So that will be 5 and 3. So you're going to bring that over. That's going to be there and there. And guys, after you've done this, there's a quick and easy way to know where your points must be connected. And I know some of the students struggle with this. So what I would always do is I would say there's a front and there's a back of the object. All right. So if I'm working around the front, then I'm working on all the numbers closest to me. So that would be 1, 6, 5, and 4. So what you're going to do is you're going to say, listen, my first cutting point is there by 1. My second cutting point is going to be in this drawing by 6, which is closest to me. So that's going to be from 1 to 6, I'm going to have a line. Now have a look here. There's the cutting point for 6. That cutting point over there is actually cutting point, if I'm just quickly going to look at this, according to this drawing, this is number 5. This one over here is going to be 4, as you can see it. then it goes back there around the back of the drawing. So it first goes around the front, then around the back. So at the back I'm going to cut on number 3, then I'm going to go back to number 2, and then of course I'm going to go back to 1. Okay, so once again it's 1, 2 around the front, then it goes to 0.5, so it's going to be from 1 to 6, and from 6 to 5. So if those of you are unsure, that's 5 on the prism. This is 0.6 on the prism. 4, then I've got 3 at the back, and I've got 0.2 at the back and 0.1. So it's going to be 1, 6, 5, 4, then it's going back, 3, 2, and 1. Guys, and that's why it's important to, as you bring your lines over, mark them. Can you see these 2? Then you mark it as 0.2. Then it's not that difficult to do it. Guys, once I've done this part of the prism, you guys will see the blue part is still there. Why? Because you guys can see everything from that point 6 and 2 downward. That part is still there. So that part is still there. That part is still there. But the rest of that part up there has been sectioned away. It seems that that line is there. But that line 5, 6 is actually the line that's going to be lying over here. And that's what you are actually seeing in this view over here. Okay. The next thing I quickly want to mention is the inside. Now, once again, you've got 1, 6, 2. Remember, I use the same numbering system, but I'm just going to take another color to just show this to you guys. I'm going to use the orange. There's the orange. 1, 6, 2, 5, 3, and then obviously 0.4. So guys, those are the points that I'm working with now on the pyramid. So on the pyramid, once again, I need to know what are the points I'm working with. I need to number them. As I'm marking them and taking them over from the one view to the other, I must number my 1, my 2, my 3, my 4, my 5, and my 6, which would obviously be at the top. Guys, and then once I've got those lines, I can then go and plot my cutting points. Now I want to show you guys, here at the bottom I've got 0 and 1. So 0, 1 is that line there. So that cutting point would lie over here. So that is actually 0.1. Then I'm having 2 points now to see what's going on. 6 is closest to me over here. So as this object turns, if you're unsure, you can see 6 is on this side. So if you project it there and up, this is going to be 6. Can you guys see there? If you actually take this over, I'm just going to work with 2 triangles. So if I take this line over, I take it 90 degrees up, you guys will see that it corresponds with that same point. It will corresponds with 6. Alright, so there's another way of getting 0.6, but you can also take it up, see that is 6, and then take it over. It's the same thing. Okay, the same applies for basically for 0.5. You can project it over and up, or you can project it straight from here, and you'll get those 2 points. So this is going to be 6, this one is going to be 5, 4, there's number 3, there's number 2, and obviously 0.1. I'm going to mark it on here for you guys as well. So this is 1, 6, there's 5, there's 4, there's 3, there's 0.2, that you guys can clearly see it. Okay guys, once I've done all of this, the only area, because it's a solid object, everything else will be slightly raised. You can leave your construction lines, but it must be faint. So in other words, the parts that are removed must be really faint. If it's at all, if you just have all your visible lines there and it's impossible to see what's going on and it's not construction lines, we will penalize you for that in the exam. So please just remember that. But please leave those construction lines. I'm just saying that it shouldn't be, a construction line is not an outside line. If you take it a meter away, you should barely see it. Okay, that's a good test for a construction line. Okay guys, with that I'm going to conclude with this video, and I'm just going to do, in the next video, I'm going to quickly cover with you guys the drawing of the true shape of the section. Now, just before we go on, the issue here is when I'm looking at the section plane, I'm looking 90 degrees on it, but it's an angled plane. So the problem with that is all my views, the plane is basically angled. So although I see straight lines here, I cannot measure them and say, listen, that line is a specific length, because you cannot measure it, it's at an angle. And that's why we have to draw the true shape of the section, that we can actually measure these lines and say, what is the actual length of those? Think about if I've got on a car or on an aeroplane, there's a window or something at an angle on a roof, and I need to cut a piece of glass or perspex that perfectly fit that shape. Then I'm going to need the true shape of the section. And that is the reason why we need to be able to do this in a drawing, so that we can give it to somebody that has to manufacture it, so they can actually know what the real size of it is. Okay, so guys, I hope this helped you a lot. And like I mentioned in the last video, I'm only going to explain to you guys how to get the true shape of the section. Have a wonderful day further.